Okay, grade 11 and 12. Let's work on calculating the pH of a base. Let's look what we have here. Calculate the pH of a 0.4 mole per decimeter cube of sodium hydroxide. So sodium hydroxide is a base. So now there are steps that you need to follow to find the pH of a base. Number one, write down the balance equation for what? For dissociation reaction of the base. So you're going to take this guy will undergo dissociation. That's what happens when you add the base in a solution. Yes. So now I'm going to take this and the sodium hydroxide. So the sodium hydroxide, it will dissociate in water to form what? So now we know that a base, they form the OH in a solution. So this will be OH minus. So the OH minus, it will be in aqua solution. So now remember the sodium is in group 1. So this is just Na plus, which is in aqua solution. So once you have this balance equation, it's easy for you to identify the concentration. So now remember the pH formula, it says pH is equals to negative the log of H3O plus. We need to find the concentration of that H3O plus. I know someone is already asking, how can we get the H3O plus out of this equation? Please, just make sure that you stay in the lesson. Everything will make sense. Now, look at this. We are given the concentration of this, which is 0.4. So this is 0.4 mole per decimeter cube. I need to use the mole ratio. So now I know that the mole ratio of this, I have it as 1:1. So that's the mole ratio. So my mole ratio is 1:1. This tells me that even this one will have the same mole ratio as that base, the OH, mole per decimeter cube. So now I can conclude and say, therefore, the concentration of the OH minus, we just calculated using the mole ratio, which is 0.4 mole. Right, so now this is where everything starts to get more and more interesting. How does this guy, the concentration of the OH minus, how is this going to help us to calculate the pH of this base? Remember, we need to use what we call the KW to calculate the concentration of what? The concentration of H3O plus. So if you still remember the formula for the KW, the formula that we use for KW, it equals to the concentration of H3O plus multiplied by the concentration of OH minus. Ladies and gents, remember that we have the concentration of this, and this is always given. So Kw, the ionization constant of water, we know that this is 1 multiplied by 10 to the power negative 14. We equate this to the H3O plus, which is what we are looking for, multiplied by the concentration of OH. We have that as 0.4. We can make this hydronium ion subject of the formula by dividing both sides by the 0.4. Divide this by the 0.4. Please give me a second to find this on my calculator. I'm just gonna allow my calculator to make the magic and tell me what is 1 times 10 to the power minus 4 divided by 0.4. Okay, so when I put this on the calculator, this divided by 0.4, we have an answer of 2.5. This is 2.5 times 10 to the power negative 14. And this is mole per decimeter cube. So now I think everyone understands why when we calculate the pH of a base, we start by finding the concentration of the OH so that we can use the KW formula and isolate our H3O plus. So now pH, it's equal to negative the log of the concentration of H3O plus. Just do your substitution. This is then negative the log of that, which is 2.5 times 10 to the power minus 14. Put this on the calculator. Let's see what we have. What will be the pH of that base? Okay, I'm also putting this on the calculator. Negative the log of 2.5 times 10 to the power minus 14. So I have this as 13.0 at 13.602. So it's up to you how you're going to run off this guy, because remember in an exam they might say run off to 2 decimal place, which will be 13.60. I hope now you understand how to calculate the pH of the base. First thing first, you write down the balanced chemical equation of the dissociation reaction, and then you use the mole ratio to find the concentration of this guy. Always the base will give you the OH minus. It's always the case. Né? So once you have the concentration, use the KW formula to find the concentration of the H3O plus. And that's it for this lesson. If you liked the lesson, if this lesson really helped you, please make sure that you join the family by following us. If you're watching on TikTok, follow the family and we'll make sure that you feel at home. And if you're watching from YouTube, make sure that you hit the subscription button, like and comment on the video so that you don't miss the next lesson.